today we'll be learning about the Pythagorean Theorem. The Pythagorean Theorem is used to help find the lengths of the legs and hypotenuses of a triangle. I will explain what those are in a bit. So the Pythagorean Theorem only works on right triangles. This is a right triangle, and the Pythagorean Theorem goes as follows. It is a squared plus b squared equals c squared. Okay? So that's this. A squared and b squared are also legs. So what we could write this as is, so this right here is a leg and that right there is a leg. That is the hypotenuse. So essentially what this is L squared, or leg squared, plus the other leg squared equals hypotenuse squared. Here is another right triangle. I have labeled both of the legs, and now I need to figure out what the hypotenuse is. So, to figure out what the hypotenuse is, do this as how you normally would do an equation. So first you write out the equation. A squared plus b squared equals c squared. Remember, this is always c squared. The longest side is always the hypotenuse. These are both of the legs. So we could have them anywhere. We could do 5 squared plus 2 squared, or 2 squared plus 5 squared. I'm just going to do 2 squared plus 5 squared equals c squared. So now what we have to do is we have to square these up because they are exponents. They become next in PEMDAS. So it's 4 plus 25 equals c squared. And then we add them together and we get 29 squared. No, not squared, sorry. I messed it up. Big time. Alright, so this is a right triangle. You have to label it as one. I forgot to do that. So, now, if anything, we have both the legs, and we need to figure out the hypotenuse, also known as c. So, to figure that out, we first have to write out the formula. B squared equals c squared. Okay? Then we have to fill in the formula. You could have 4 squared plus 5 squared equals c squared, or 5 squared plus 4 squared equals c squared. It doesn't matter because both of them are the legs. So I'm just going to do 4 squared plus 5 squared equals c squared. Right? Now we have to square up the numbers. So that is 16 plus 25 equals c squared. And then you do 16 plus 25. Okay, 16 plus 25, you can use a calculator for this because you will be able to use a calculator for the Pythagorean Theorem. I think we get 41. With 41, we put 41 here. 41 equals c squared. And now to get 41 to equal c, we have to do the square root of 41, which is that, and we round to the nearest tenth, so c equals about 6.4. Okay, so you might have to use the Pythagorean Theorem in different ways. So this way, you know one of the legs, the hypotenuse, but you do not know the other leg. So you have to figure out what the other leg is. So first you write off a squared plus b squared equals c squared as usual, but now you fill it in with 2 squared plus b squared equals 10 squared. Okay, then you square the numbers, so 4 plus b squared equals 100, and then you subtract 4 from this side, but what you do to one side you have to do to the other side. So we subtract 4 from here, and we subtract 4 from here, leaving us with b squared equals 96. And then we find the square root of 96. 96 square root equals about 9.8 if you round to the nearest tenth. So b equals 9.8. We've gone over the two ways two of the three ways that you can see it, but both the ways that you can do it. So first times you may see it in a triangle form with the hypotenuse missing. Then you might also see it in a triangle form with the leg missing. But there's one final form, and it's written like this. You know what A and B are, but you don't know what C. Instead of showing you a triangle, they just show you the variables and what they mean. So you write the formula as usual: A squared plus B squared equals C squared. After that, you apply the numbers. So 3 squared plus 7 squared equals C squared. Then you square the numbers. 9 plus 49 equals C squared. And you add the numbers, which is 58 equals C squared. Then on your calculator, you type in 58, and you press the square root button, and it equals 7.7, or around there, because you round to the first. So C equals 7.7. That's it. That was easy.